The deeper we dive into space, the more incomprehensible and hostile it becomes to live. Sometimes, even hypothetical space monsters are not as frightening as ordinary planets. A Neptune-like gas giant will leave no trace of humans with its constant rain of glass. While two zombie planets orbit a long-dead star in the constellation Virgo, suffering from radiation every day. Today, we're going to take you on a short journey to planets that you would hardly want to visit in reality. HD 189733b. The first planet in line is the blue gas giant, HD 189733b. It's slightly larger than Jupiter, but unlike the largest planet in the solar system, HD 189733b is only 29,005,798 miles away from its star. For comparison, the distance between Jupiter and the Sun is almost 166 times greater. Therefore, one orbital period of HD 189733b around its star takes only 2.2 days, with an orbital speed of 134,000 miles per hour. The star around which the gas giant is moving is a K-type star, or orange dwarf. Such stars have lower temperatures than, for example, G-type dwarfs like our Sun, but they have a longer lifespan. These factors make these stars very promising for the development of life on planets in their systems. But the planet we're telling you about is definitely inhospitable to any life forms we know. HD 189733b is too close to its star. According to various sources, the giant's temperature reaches almost 2,000 degrees Fahrenheit, so it belongs to the class of hot Jupiters. In particular, it can be turned only one side to the star, but according to the Spitzer telescope. Despite this, its surface still has a fairly high temperature around the perimeter. But that's not the only reason why HD 189733b is a life-threatening planet. I wonder why this planet is completely blue. Another gas giant, Neptune, as far as you know, has the same color because of its dense methane clouds. However, although there are traces of methane on HD 189733b, it's too hot for the gas to condense into clouds. In particular, there's no water there, only water vapor. So why does the gas giant have a similar color? This blue color of the planet is probably due to its strange atmosphere, which has reflective silicate clouds that form droplets of glass. On HD 189733b, rains small glass particles. Moreover, along the horizontal, however, remember the planet's rotation speed. Because of this, its winds can reach almost 6,000 miles per hour. Super-fast storms on HD 189733b with glass impurities could cause fatal harm to humans and very serious damage to other matter. So, the weather on this gas giant is dangerous, to put it mildly. In addition to glass storms and high temperature, HD 189733b is also very strongly irradiated by its star. The planet loses 100 to 600 million kilograms of atmosphere per second. Therefore, it's unlikely that anything would be able to survive on this deadly planet. From all sides, you've probably seen images of hell before, a hot and creepy place filled with lava, uncovered in black soot. The next two planets, 55 Cancri and K-141b, can confidently claim to be real hell worlds with oceans of lava on their surfaces. 55 Cancri is a rocky planet almost 8 times the size of Earth. It orbits at a distance of only 1,394,337 miles around a calm and rather cold red dwarf, located 41 light-years from the Sun. It is the closest planet in the system. In addition to it, there are 4 other confirmed planets, all of them are gas giants which are also very close to their central star, except for the last one, 55 Cancri d. A year on 55 Cancri lasts only 18 hours, and only one side of it is likely to be irradiated. Thus, the temperature of its side facing the star can reach an average of 4,200 degrees Fahrenheit, and the unlit side averages from 2,400 degrees Fahrenheit to 2,600 degrees Fahrenheit. However, Lexis Brandiger, a researcher at Stockholm University, has noticed that the hottest spot is moving and the temperature around it is varying. He concluded that the planet may be in resonance with its star, which means it has a day and night cycle. However, the ultra-high temperature of the illuminated side indicates that this part of the planet may be molten and thus completely covered with a layer of lava. It is not known for certain whether the alleged night side is covered with lava. According to astronomer Ren Hu, the entire planet should be covered with lava. Moreover, 55 Cancri most likely has a dense atmosphere that can hide layers of lava. It consists mostly of the same elements as Earth, mostly hydrogen, helium, as well as nitrogen and oxygen, but no traces of water vapor have been found there. So if this planet can have an atmosphere and still be in resonance with it, then it can cool down. But then this hellish whirl becomes even more dangerous. If the silicate surface heats up and evaporates during the day, then the vapor would cool down overnight and, like on HD 189733b, would create some precipitation, namely lava drops. Add to this the very fast movement of the planet around the star, and we get the likely hot storm with lava rain. Finally, such proximity to the star can cause volcanic activity on the planet, which can also increase the planet's temperature by blocking heat emissions. K2141b is also a rocky planet that orbits the orange dwarf at a distance of 202 light-years. It's almost 5 times larger than Earth and also has a density of 1.5 times more. But it moves at an even smaller distance from the star than 55 Cancri, 694,379 miles. Therefore, 1 year on this planet lasts only 7 hours, making its orbital period one of the shortest known at the moment. The hellish winds can reach speeds of 5,000 miles per hour. There, the planet is most likely blocked by tides. Its illuminated side can have a temperature of 5,430 degrees Fahrenheit, while at night, the temperature drops to -328 degrees Fahrenheit. Likewise, the daytime side is completely covered by lava ponds at depths of more than 62 miles. Moreover, like our Earth's oceans, K2141b has a similar magma cycle. The silicate rocks vaporize and fly at supersonic speeds to the cooled side, where they condense and return to the hot side and fall out pebbles down, where they evaporate again, forming a thin layer of atmosphere and keeping the lava in balance. This is very similar to the weather on the previous planet. But because K2141b is blocked, its precipitation has time to cool and therefore falls as rocks rather than lava. However, some studies indicate that the flow of minerals back to the illuminated side may be too slow, which could theoretically create an overload on one side and change the planet's rotation on its axis. Thus, the atmosphere of K2141b consists of solid elements sodium, sodium oxide, or silicon dioxide, meaning it has the same composition as the surface. Our Earth probably looked like this at the beginning of its formation. But it's highly doubtful that these two planets will ever be able to give any life a chance to develop. Kepler 70b, however, 55 Cancri and K2141b both pale in comparison to the theoretical Kepler 70b, a rocky planet that's hotter than the Sun itself. Kepler 70b, or KOI 55b, is probably 4,200 light-years away and orbits an incredibly hot dying star with a temperature of 49,452 degrees Fahrenheit. Kepler 70b is almost half the size of the Earth, but its density is similar to that of the Earth. According to the study of astrophysicist Stefan Charbonnet, this planet may be only 557,734 miles away from the star. Therefore, the planet's surface could be around 12,000 degrees Fahrenheit. It's impossible to say exactly what the planet might look like because of the difficulty in studying it. But only part of the fried core may likely be visible from under that destroyed surface. It could have been a gas giant before, but it lost its shell. There's also another planet in this system, Koi 55c, which is probably also rocky. They may be in a 3-2 orbital resonance, which could explain why they probably still exist. However, this is not the strangest and scariest thing that's happened to this planet. As the central star is slowly dying, it's already past the red giant stage. The stage of star death, when the thermonuclear fusion of hydrogen in the envelope begins due to the end of hydrogen reserves in the core. During this phase, the star begins to grow and absorb nearby planets. And since Koi 55b probably continues to move around the star, it has most likely spent some time inside its dying star and survived. When the planet, hypothetically a gas giant at the time, was inside, it could have completely lost its gas and liquid envelope, which is why it has that scary, half-dead appearance. In addition, it may be evaporating due to the influence of its star, so maybe the planet doesn't have much time left. So far, the existence of both planets has not been confirmed, and the signals from the system received by the Kepler telescope interpretations vary. Proximity to one star is rarely favorable for the planet itself or possible life there. Another planet, Toi 849b, like the hypothetical Koi 55b, has only one burnt core left due to the influence of its host star. Toi 849b was probably a large gas giant, the size of half of Saturn. Although it's possible that by the time the gas envelope was destroyed, it could have had the mass of Jupiter. However, it's also believed that it could have been a failed giant that failed to gain enough material during the protoplanetary disk phase. It orbits a Sun-like star at a small distance of 1,480,533 miles, so its temperature reaches about 2,800 degrees Fahrenheit. Because of its close proximity to its star, the gas giant has no trace of an atmosphere. In particular, even as a very dense, heavy, and giant exoplanet, it has very little hydrogen and helium, although this is really strange. If Toi 849b is so massive, then its gravitational forces should be able to hold on to a giant gas shell. However, according to research by scientists from the University of Geneva, even if this planet had formed farther from the star, or indeed was the size of Jupiter, it would still have lost all its gas due to too much radiation in 50 million years. Such planets that have lost their envelope are called chthonic planets, meaning they are connected to the underworld. Toi 849b actually resembles an empty, hellish wasteland that could have been quite different in the past. So, you've heard about half-dead planets that actually survive in incredibly difficult conditions. However, some planets could have been destroyed a long time ago, but eventually came back to life again. One of these amazing planets is Per B 1257 plus 12c, a planet orbiting a dead star. Per B 1257 plus 12c, also known as Poltergeist, is located 2,300 light-years away in the constellation Virgo. It's a cold and rocky planet, slightly larger than Earth, that orbits its star in 66 days. In addition to Per B 1257 plus 12c, there are two other rocky planets in this system: Per B 1257 plus 12b, known as Draga, with an orbital period of 25 days, and Per B 1257 plus 12d, Fulbator, with a period of 98 days. However, their star is already at the final stage of its life, in the form of a neutron star. This means that it should have already exploded into a supernova and destroyed everything nearby, including massive planets. However, these planets continue to exist, which is hardly possible. Scientists believe that a massive protoplanetary disk may form around the pulsar from the remnants of the supernova, and in particular by capturing part of the nearest cosmic body, such as another star. The material that could remain after the evaporation of the planets, if they existed, would hardly be enough to restore them. So, the presence of a companion star explains the massiveness of the newly formed planets. In particular, there is another theory that explains the formation of planets by combining two white dwarfs. The less massive dwarf could collapse due to the impact of a larger star and then absorb the residual material until it reaches a huge mass, which would lead to the collapse of the core and the formation of a pulsar. Then the disk remaining after all these processes could be sufficient for the formation of planets. All planets can experience strong radiation exposure, although it's possible that due to the distance of the planets, it would not be too great. So far, no system similar to Purby 1-57 plus 12 has been found, but the discovery of pulsar planets has really struck researchers as paradoxical. Tres to b. And finally, 750 light-years from our Sun, is an amazing planet of endless night. However, it's not just a planet with one side blocked by the tides. You won't be able to see anything at all on Tres to b, even if you have a flashlight. Tres to b is a gas giant larger than Jupiter. It orbits very close to its Sun-like star, so it's classified as a hot Jupiter. However, unlike all the gas giants that scientists have come across, this one is definitely one of the strangest and most interesting. Tres to b is completely black. Its surface reflects light worse than coal or black acrylic paint, meaning it absorbs more than 99% of the incident light. However, since it is a very hot planet, it's likely possible to see a red glow from its interior. However, what causes this unusual color of this gas giant? It's impossible to say for sure what the cause is because of the vast distance, but astronomer David M. Kipping suggests that one reason for the lack of reflective clouds of ammonia, as on Jupiter, due to the high temperature of about 2,930 degrees Fahrenheit. Instead, its atmosphere likely contains light-absorbing chemicals like sodium and potassium that evaporate. Still, this is not enough to explain the planet's deep black color. So if you were to find yourself on Tres to b, in addition to the endless darkness through which you would hardly be able to see the stars, you'd also be exposed to hot supersonic winds. It just doesn't sound very safe. Space beyond Earth continues to fascinate us, even if some planets make us scared. After all, not all planets can be considered suitable for life. Some of them may be a direct threat to any living organisms. Nevertheless, even the seemingly dangerous planets are worth studying to add to our knowledge, even to learn about the history of our planet's formation. No matter how scary space may be, its exploration is the key to our further development.